Hi all, I am Darshita, Chief Technology Officer of the company Decipher. Chandana is our Chief Executive Officer. Fawaz Abdulmajid is the Chief Operating Officer and Fatima Hadi is the Chief Financial Officer. I am here to present about Li-Fi. So these are the contents of the presentation. Let me move to the introduction. Li-Fi is short for light fidelity. It is a wireless communication technology which utilizes light to transmit data and position between devices. The term was first introduced by Harold Hash during 2011 TED Global Talk in Edinburgh. In terms of its end use, it is similar to Wi-Fi, but the key difference is that Wi-Fi uses radio frequency to induce a voltage in an antenna to transmit data, whereas Li-Fi uses the modulation of light intensity to transmit data. So let's see what is the need of Wi-Fi. Wireless communication has become an essential thing in our day-to-day life. We have 6 billion base stations deployed worldwide and we have more than 5 billion of cellular mobile phones. And with these mobile phones, we transmit more than 600 terabytes of data every month. So the radio spectrum is getting saturated. So these are the different electromagnetic spectrum and their potentiality. Let's see how Wi-Fi overcomes some of the Wi-Fi issues. Capacity. Visible spectrum is 10,000 times greater than that of radio frequency. It is highly efficient since LED consumes less energy and also light waves are available everywhere. When we talk about the security, light waves cannot penetrate through walls, hence data cannot be intercepted. Let's see how Li-Fi works. Li-Fi uses visible light as medium of transmitting data. White LEDs are used here. When the LED is on, the digital data 1 is transmitted, and when LED is off, the digital data 0 is transmitted. This on and off process occurs at extremely high speed that are unperceivable to human eye. There is a controller connected to the backside of these LEDs. It is used to code the data. Now let's see the components. At the source, we need a bulb, PCB, PA and an aluminum enclosure. And at the receiver side, we need a silicon photodiode. So at the source, white LED is normally used. The power amplifier is used to generate an RF signal and is guided into an electric field about the bulb. The PCB controls the electric input and output of the lamp. All these subassemblies are contained in an aluminum enclosure. So this is the silicon photodiode which is used at the receiver side. Let's see the receiver circuit. At the receiver end, photodiode is used as transducer, which convert the light modulation into electrical impulses, which can be processed in system processor. A transistor-based amplifier circuit is used to enhance the signal strength. A microcontroller is used as a system processor for demodulation and processing the encoded data. Let's look at the implementation. All the data from the internet is streamed into the LAN driver. This data is used to modulate the intensity of LED light source. The photodetector picks up the signal. The receiver dongle then converts the tiny changes in amplitude into a data stream. Li-Fi connector. Optical signal cannot penetrate through walls. Li-Fi room connector is a replicator which sends the data from one side of the wall to the other via an optical fiber. Li-Fi router. It serves as a connector to external link like DSL. It covers a radius of about 20 meters. Transmission speed is up to 100 Mbps and it is suitable for small offices or home use. Let's see the applications of Li-Fi. It can be used in sensitive areas such as aircraft for data transmission without causing interference. Places where it is difficult to lay optical fibers like operation theaters. Traffic scenarios, thereby reducing accidents. Underwater applications where radio waves cannot propagate. Industries like petrochemical plants, nuclear power plants, petrol pumps, etc. So these are the setup in an aircraft. And let's see how it works in transportation system. The car headlights and tail lights can be replaced with LED versions. This offers car-to-car communication over Wi-Fi. That is, when two vehicles or two cars are close to each other, both the drivers will get a message, and hence the accident can be prevented. In home and small offices, it is predicted that the future home and offices will be reliant to Wi-Fi for being fast and secure. Let's look at the limitations. Since visible light cannot penetrate through the solid object, it can be easily blocked. So there is a small mistake in the second and third points of the slide. It is said that the major challenge in Wi-Fi is how the receiving device will transmit back to the transmitter. So actually Wi-Fi is a two-way communication system. It has uplink and downlink, and it is possible, it is not a challenge. And the third point is said that interference from external light source like sunlight in the path of transmission will cause interruption in the communication. Actually, sunlight does not cause any interruption in the communication. A company known as Pure Li-Fi conducted a lot of experiments in the presence of sunlight, and the Li-Fi system worked perfectly. So that was a mistake. Let me move on to the conclusion. Li-Fi is not a complete replacement for Wi-Fi. Li-Fi is a companion for Wi-Fi. Wi-Fi technology can be put into practical use. Every bulb can be used as an alternative to Wi-Fi hotspot. It provides simple, faster, and efficient wireless data communication. Wi-Fi will make us to proceed towards the cleaner, greener, safer, and brighter future. Thank you all.